All right, I'm going to draw a penny from multiple points of view here myself too. I think my points of view will match what many of you have come up with. I have a penny here. There's a picture. Probably saw that one from yesterday. Quickly, yesterday we worked on 3D, right? This is isometric because the vertex is the closest thing to us. The sides move away on 30-degree angles, right? And if we took each face of the object and drew it separately, we would see it laid out like this. The top of the object is this face here. This is the side of the object, so you only see this face here. And this is the front as if it's spun around this way. Do you see this power tool? So they're showing it up here in isometric perspective in 3D. You can see the object here in isometric perspective. And isometric is to show what it's going to look like when it's all finished, right? The aesthetics, you can see different sides of it in one view. What we're going to work on today, orthographic projections, orthographics, are being able to position different views of the object so you can get to see each one of its faces. Okay? This is more something that you would give, if as the designer, you'd give this to the person who's going to make the thing, and they'll be able to look at your pictures, at least the top, front, side view, and all your dimensions and everything else, and they'll be able to figure out how to make it exactly as you designed it. Ortho, O-R-T-H-O-G-R-A-P-H-I-C. Orthographic sketch. I'm going to put 2D in parentheses up here. So just to be clear, yesterday's pictures all popped off the page. They were 3D. You could see length, width, and height. These pictures are only 2D. They should have just width and height. You wouldn't see the depth, though, because it's a two-dimensional picture. How many dimensions is this picture? Jason? 2. It's got height. It has width. That's a valid picture of a penny? What view would you call that if you had to name the view? Take a guess. It's okay. Yeah. You could call it a forward view. That's a good guess. It actually begins with an F, but they're going to use a different word. Front view. You nailed it. I'm going to label this view in all capital letters, the way architects, designers, and engineers would do it. Front. That's a good picture. Very simple. Which one of these things is not like the others? Which one of these pictures definitely is not a 2D picture? Aaron?
That one.
Yeah, the one on the end. I can see the top view of the penny or the front view, and I can see some of the side too, right? So that's a 3D picture. It's got length, width, and height. We'll erase that one from here. Not necessary. And then I have these two pictures. One of them is the correct side view of the penny. One of them is the correct side view. So if we took that big circle like this, if this was a penny here, right? This would be the penny from a side view. Would you think that a penny would be a rectangle when you turn it sideways? You wouldn't, right? Well, look at this paper towel roll. It's also a cylinder. What shape is it when you look straight ahead at it? Yeah. It's a square over here. That's a corner. And a corner here, and a corner here, and a corner here. It's flat on the sides and flat on the top at a perpendicular angle. From a front view, this paper towel roll looks like a rectangle, doesn't it? And same thing for the penny. If I turn the penny sideways from front to side, all you would see is this part here. You wouldn't be able to tell that it's popping out like this but you would see that shape over here in the front view. Does that make sense? All right, so I'm going to label this one here side. All capital letters. And I'll erase this one view I don't need. Front and side. I really couldn't have another view. I guess besides front, I could do the back side, right? There could be 3 sides to this object. And what I'd like you to do is put a line between the two of them. So we separate the two views. Excellent. And I'm going to now move from drawing the object to putting dimensions on this object. So if I wanted someone at the mint to make my version of this coin, I'd have to give them a picture of the coin as an orthographic where you can see the different views and all the dimensions would have to be there. So they're going to need to know length, width, and height. And if I put a picture of the height over here or a dimension for the height here, because it's right next to the front view, I wouldn't have to put the height here also. We'd only have to do it in one location. But the way we draw those dimensions is very different than maybe how you do it in a math class. If that penny was 1 inch across, you would have to label the penny as 1 inch outside of the penny with this special line that has arrowheads on each end at the top and bottom. It tees off with arrowheads. You split it in the middle, put the dimension, and it sits at the same height as the front view of the penny. Now everybody knows this penny is 1 inch high. If that's the case and I don't need a second dimension, what do you think about putting the height over here? What do you think? Do we need to do it, Jason? No, follow your gut, you're right. No, we don't need to. It's the same height whether you turn it sideways or frontward, so we just have to put that height once. What dimensions do we still need? We need a width. I can get the width right here on the side view. It's so small I can't even fit the letter W in there. So what you can do on your paper is bring a special line out called a leader line. It's kind of like a label. But pull that leader line out so that you can put the dimension elsewhere where you have space to write it. And I can put a height. It may seem confusing that I'm going to put a height here like this because you might think of this as width. But it can be the height also. Put an H in inches. There's one more way we could have done the dimension for the height or the length. Instead of putting a long line like this, is there another way I could say that? A circle, a perfect circle is a certain dimension going all the way across. What's another type of a measurement besides krill? I could say something about the degrees, and that would probably be like the circumference. How many around? The distance around, that's one way, all the way around the circle. Or the distance straight across the circle. What do you call that? The line that cuts a circle in half. Danny?
180. Oh, semi.
Yes, both of these things are right. It's a semicircle, it's cut to 180 degrees.
Oh, a straight line angle?
What would that be measuring? The line across the circle. It begins with a D. DI. Diameter. Oh. So if I wanted to get rid of these two dimensions, because it's a circle, the height and the width or the length are going to be the same, I could just do one leader line and say diameter equals whatever. But we're never going to write on the object itself. If I wrote a dimension on the face of this penny, if I put 5 inches here, like you see in a math book, the person who gets my design over at the Mint where they make the coins might look at that and say, I think Chris wanted us to engrave the number 5 on the front of this coin. Because architects, designers, and engineers always keep all dimensions off to the side of the object. Everybody's doing this with a pencil, right?
Yeah.
Great. If you want in the future, you can do these pictures also with a ruler, and eventually we're going to do them on graph paper. Okay? All right, follow these rules and draw a new object for me. But before you draw it, let's add one more rule. Alignment. Alignment. Pay close attention here, Krill. Alignment is when things line up with each other, right? Right now, these desks have alignment. All of them, most of them, are sitting at the same position all the way down the line. Because the bottom of this penny and the top of the penny in both views are at the same place, this picture has alignment. But if I drew the two views like this, let's say I did one here, and then I drew the other view over here like that, does the picture have alignment anymore? No. So this is bad. We're not bad, but we don't want to do it like that. Boo! So take the rules we just learned about objects, dimensions, aligning views, and draw a can of soup from a front and a top view. Yes, but this can of soup's not in 3D. It's in top and front view. And if you want, you can put a label on there and draw a picture to tell us what kind of soup it is. Maybe a different soup than you had picked yesterday. Hands free, eyes on me. I know you're not, some of you aren't quite finished. Just take a look up here. This is a 3D can of soup. That's isometric view, right? We could see the top and the front at the same time. That is not what you should have right now, though. Right now, for our can of soup, we have two views, so I'm going to make another one of these quadrants up for myself. Bless you. Here's the top of the can of soup. Maybe it has that little thing on it for popping it open. And then, should this be the side view or the front view here? Do they have alignment? Do the top of this picture and the bottom line up with the top and bottom there?
No.
What do I have to do to put these pictures in alignment? Josh?
Rotate the side view on 90 degrees.
I could rotate this to a 90 degrees and go this way with it. You could. But do you usually see cans of soup laying on their side that way? So its most natural position, Josh, would be to move it below here. Bless you. Are you allergic to cans of fake soup?
Yeah.
Now do the views have alignment? Only one person? Do these views align now?
Yeah.
Yes. Label it. Top view. All capital letters. Side view. Put a little label here. I need some dimensions. Maybe the height. How many inches should it be?
5.
Can of soup, 5 inches tall? Do 5. Make sure your dimension lines have arrows on each end and they tee off. All right, let's try up here. We will do diameter for this part. Leader line, diameter equals, how many inches across would that can of soup be? This is 5. This must be a little smaller. Yeah, 3 works. 3 inches. How do you feel about that? Good? All right. I'm going to throw a curveball at you. Draw another picture for me. Top view, side view, or you call it front view. And I want you to do this roll of paper towels. And you can position it the way you'd see it in the kitchen on one of those paper towel racks that sits like this. Or you could position it assuming that it's hanging like this in the bathroom. however you want to do it. But make sure your views have alignment, add dimensions, and use your pencil. We don't have rulers at the table, but if you had them, you'd want to use them to make straight lines. Here's the hard part. Figure out how to show me the tube. Figure out how the tube would be expressed in this picture. All right, take a look up here at the board. I'm going to modify my can of soup to work as my paper towel roll. So I'll take off the tab. I'll pull out this dimension here. Take this dimension out here. Get rid of the label. And I'm back to having a paper towel roll. Eyes up here, folks. Eyes up here. Back to having my paper towel roll. You could have also drawn the paper towel positioned this way. That would have worked too, right? Because they have the same heights here. But you couldn't do something like this. If I had moved this view to here, I'm looking around, a few people have this at their paper. You put this next to this. Do these heights line up? No, so we have to move that view. All right, the rest of this is pretty straightforward except for the part where how we're going to handle this cardboard tube. Everybody in class had this part. That's the inner tube inside here, right? Does that piece of cardboard that's inside there, does it have thickness to it? It has to. It's a 3D, it's a real object, right? So it's got length, width, and height. So would one circle work for that picture? If you wanted to get really specific, you would need a concentric circle in there. Mine looks more like an egg, sorry. I exaggerate a little bit, but because I would want to tell the person who's making the paper towel rolls at that factory in Michigan that this has a certain thickness to it. How do I show the paper towel roll tube going through from the front view? Jason?
Make like dotted lines.
Yeah, how did you know to use dotted lines? Really? You just guessed? That's awesome. Dotted lines show hidden features. If Jason had said, well, just draw the lines on the front, and I went like this, whoever you gave the design to might look at it and go, I think Chris wanted us to glue a big ruler to the front of the paper towel roll, right? Because it would look like you're drawing it's on the outside. So dotted lines will be the way that we can tell an object is hidden. Hidden features are expressed with dotted lines. Okay, we're going to get up to something a little tougher now. A little bit tougher, I think. You might find it easy. We're going to move to a rectangular object. Whether it's a book or a cell phone or a box of gum, they're all going to be shaped like a big rectangle, right? Cell phone, box of gum. I would like you, on somewhere where you have some open space, to draw a cross on your paper, like this one up here. See, I have four squares here. One, two, three, four. And you're going to do the cell phone from a front, side, and top view. Let's give it at least 3 views. So let's see the front view here, side view here, top view here, and you can leave this open over here. All right, front view, side view, top view. If you got that pretty easy, can you draw a stapler across a cross, like quadrants? Can you make another set of quadrants and maybe do a stapler, top, front, side view? Or try a candy bar or a tissue box. I'm not going to put any dimensions on here for right now. I'm just concerned with whether or not you're getting the right alignment. Stapler, similar deal. This would be the most natural view of the stapler from the side here. This would be the front view. And a top view. You know what? For the stapler, I could do the top view two different ways. I could flip it here, do it that way. Or I could take this and flip it downwards. It would be like if I looked at this from the side, and then I flipped it to the front, and you looked up at this part here, and then I went to the top view like this. So you could put that here, or you could put it in this position. Either one works, but only one. Just pick one or the other. What do I have here? It's a marker. It's a dry erase marker, right? It's not in 3D. It's in 2D. If I wanted to do it in 3D, it would look totally different. That would be 3D, right? But this is flat, 2D. So that would be a side view. But if I want to do more than just length, width, height, what if I want to dimension the whole thing? You need to know how big the cap is, how big the little button is up here, how big is the tube. And if I were to do that, that would be like 1, 2, at least 3 or 4 different dimension lines, right? But they're all kind of going along up and down. So I'm going to do like a compound dimension line. One line broken into multiple pieces. Let's say it starts at the top here, it ends at the bottom here, and it has a part here at that height. It's got another part here at this height. And I'm going to do little arrowheads between each one. Maybe this is 0.25. Maybe in the middle here, this one is 1 inch. And maybe the tube here is 4 inches tall. But do you see how we put it all in one single dimension line, broken into 3 or 4 parts? So for homework this evening, you don't have to write it down, just listen and remember it. For homework this evening, you're going to pick an object, something from your bedroom or anywhere you like, and then do an orthographic sketch of it. Give us at least a top, front, side view, have dimensions, make sure they're aligned properly, and try to pick something a little more complicated than just like a brick. And let's not do anything round, no cylinders. The cube stuff's a little bit tougher for orthographic. Top, front, side view, pick any object you want. And you can do it on plain paper, but if you have graph paper laying around, you're more than welcome to use it. Eventually these pictures will be on graph paper. Which one was more fun, isometric or orthographic? See, everybody, it's a little different for everybody. I can't stand orthographics. No fun. These are no fun to me. I like the isometric. One object, 3 pictures, top, front, side view. So you can even take a piece of this extra plain paper home, draw a big cross on it, and know that your object will get placed in 3 of those boxes.